Assalamu alaikum guys. Mr. Atiq is here once again from the science department, and we have week 12. This is the physics lecture. We are studying chapter 20. This time we will study a new section, section 4. The pages ranges from 715 to 718. The section name is electromagnetic waves. Look at the name, electromagnetic waves. The waves which comes from electrons, electricity, and magnetics, magnetism or magnets. Combinedly or collectively we call them electromagnetic, the waves. Okay, the preview of this chapter or this section, you can say. First are the objectives as usual: propagation of electromagnetic waves and electromagnetic spectrums, in which we will study how different rays ranges from as far as their frequencies are concerned. Either they will be short or long, or like dangerous, or how much they are useful for us. All those things we are going to study in this section. Electromagnetic spectrum in the preview section. This is the main area of concern for us. Objectives: look at, first of all, describes what electromagnetic waves are and how they are produced. What are electromagnetic waves and how they've been produced, how they can be produced. Okay, then you need to know, recognize. Okay, we will try to learn that electricity and magnetisms are two aspects of a single electromagnetic force. Electricity, as I told you before, electricity from the AC, flow of electrons, charge, current, etc., etc., and the magnetisms are two aspects of a single electromagnetic force, of course. So they will produce, if electricity and magnetism combine, they will, combinedly they will, or collectively you can say, they will produce a force. We call them electromagnetic force. If they produce a wave, we call them electromagnetic waves. Okay, so the combination of electricity and magnetism in the form of the wave sign, we call them electromagnetic waves. I'll explain how electromagnetic waves transfers energy. Okay, usually energy is what means power to work. Okay, energy can be transferred, as the law of conservation. Before, you people studied so much regarding the law of conservation of energy, that energy can neither be produced or not destroyed. It can be converted, it can be transferred from one place to another, like from one form to another. That is what transfer of energy. So of course, how electromagnetic waves can be transferred, or how they can transfer the energy. Then description, like describe various applications of electromagnetic waves. These are like usually like the medicinal or medical applications of electromagnetic waves are considerable for us. The rest, leave it to the scientists. Propagation of electromagnetic waves. Electromagnetic waves travel at a speed of light. Whoa, c. Speed of light, what? C. There was a phenomena. Let me describe it like C. Okay, electromagnetic waves travels at a speed of light, like they are so much fast, and are associated with oscillating perpendicular electric and magnetic fields. Oscillation and perpendicularism here. Perpendicular, so of course it will describe us what? Electricity. And oscillation, that is what? The magnetic one. Remember, perpendicular waves, they will produce the sine theta, and the sinusoidal wave, and the electrical waves, or any kind of waves like AC currents, if you consider, they are making sine theta because they are perpendicularly propagating. Okay, oscillation for the magnetic fields. Electromagnetic waves are transverse waves. Are what? Transverse waves. That is, the direction of travel is perpendicular to the direction of oscillating electric and magnetic field. Look at, for example, if the electric field is moving like in this direction, like look at my cursor arrow in this direction, so the magnetic field will be oscillating in this direction. Understand? We discussed in the class as well, like the right hand rule. Okay, so electric and magnetic forces are aspects of a single force called the electromagnetic force. Like the combination of, you can say, electric and magnetic force, when combined they produce what? Electro for us, electro from electric, and magnetic from magnetic. So we call them what? Electromagnetic force. Propagation of electromagnetic waves, they are continued, you can say. All electromagnetic waves are produced by accelerating charges. Okay, flow of electrons, flow of charge, flow of current, all those things. Motion of electrons. Electromagnetic waves transfer. Look at the name, electro and magnetics. Okay, don't get confused. Electromagnetic waves transfer energy. Yes, the energy of electromagnetic waves is stored in the wave oscillating electric and magnetic fields. Yes, of course. Electromagnetic radiation. Now, how they radiate? It is a kind of transfer of energy associated with an electric and magnetic field. Transfer of energy. Due to radiation, they are transferring the energy. Electromagnetic radiations varies periodically and travels at the speed of light. Electromagnetic radiation varies periodically, yeah, like time to time, and travels at the speed of light. That is so much obvious. The sun at different wavelengths of radiations. Look at the radio waves, infrared waves, visible waves, ultraviolet rays, extreme ultraviolet rays, and X-rays. Look at this X-ray. Okay, we didn't experimentize these infrared and ultraviolet, by the way. Radio, it's okay, well, visible for us it's okay somehow, but X-ray, this is our medicinal thing. Look at, it can give us the structure of our bones within our, within our flesh. X-rays. Okay, that's why you call them out, like they are just electromagnetic waves. They are the most powerful rays, though the kinds are different. Propagation of electromagnetic waves continued. High energy electromagnetic waves behave like particles. Woo. An electromagnetic wave's frequency makes the wave behave more like a particle, of course, and it must be, because they are so much fast. Their ranges are like so-called high, you can say, their speed of light. If any object travels from like at the rate of speed of light, so imagine that how much that may cause how much they will be like dangerous for us. This notion is known as what? Is called the wave particles duality. A photon is a unit or quantum of light. Photons can be thought of a single particle Okay, so the electromagnetic spectrum. The electromagnetic spectrum ranges from very long radio waves to very short wavelength gamma rays. Okay, or waves, sorry. The electromagnetic spectrum has a wide variety of applications and characteristics that cover a broad range of wavelengths and frequencies. The electromagnetic spectrum has a wide variety of applications and characteristics that cover a broad range of wavelengths and frequencies. Understand? Now look at, comes towards the next slide, the electromagnetic spectrum. These are like the descriptive one, and in the upcoming slide you will see like the whole picture. Okay, the radio waves, ultraviolet rays, X-rays, gamma rays, microwaves, infrared waves, and visible waves. Longest wavelength. Look at, for the radio waves, these are longest wavelengths. They have longest wavelengths. Communications and TVs are the examples. Microwaves 30 centimeter to 1 millimeter, radar and cell phones. Infrared 1 millimeter to 700, heat and photography. Visible light 700 nanometer, red to 400 nanometers. Ultraviolet rays 400 nanometers to 60 nanometers. Disinfection spectroscopy. X-rays 60 nanometer to 10 to 4 nanometer. Medicines, astronomy, security, screening. Look at, these are the uses, okay? Uses at different levels. Now gamma rays less than 0.1 nanometer, cancer treatment, can be used for cancer treatment and astronomy. Got the idea? Now look at the last page or last slide. You can say the electromagnetic spectrum. Look at, these are the wavelengths above. Then the common name of the waves. One wavelength about the same size as, it's okay. Frequencies in hertz. So wavelengths and frequencies are here. Both are propagating in this direction. Look at it. They are moving. Look at, let me, like in this direction. Again here. In this direction. They are moving. Understand? Or you can say like in this direction. But they are pulsation. Infrared. Look at 1. These are the positive longer waves and these are the shorter ones. Because negative signs, okay, for the wavelength. Radio waves, microwaves, infrared wave, visible light, ultraviolet, gamma rays and X-rays. Football field size, human beings, microwaves, needle, red blood cells, visible microchip transistor, X-rays, DNA molecule, atomic nucleus, gamma rays. Look at the frequencies ranges in hertz, lower and higher. Lower and higher. Start from 6 to ranges to 20. Here they are given. Thank you so much for the listening. Inshallah, I will upload the solution of the chapter 20, section 2 and 3 and 4 respectively. And Asim will distribute